All right. Well, I hope everybody had a good weekend, and we're going to get back at it here. Here's a little bit of the tentative schedule for this coming week. I think we're still pretty good with what I talked about last week. Monday, we're going to do 9-4, the notes. Assignment will be Tuesday. Now, Tuesday, we're going to do 8-9 review. Now, I highly suggest you get Monday's homework done Monday. And then Tuesday, you can focus on this. It will be due Wednesday at 6 p.m. Okay, that way I can post the answer key at 6, and then we'll have a Canvas conference from 8 to 8:30 on Tuesday, and then Wednesday, and then we might have a conference in the evening. We'll see kind of how that goes to kind of prepare for the test. The test will be posted at 7:30 a.m., due by 9 a.m. One thing you got to watch is when solving some of these problems, if you get stuck, you can spend a ton of time wasting, just wasting your time on one problem. Sometimes you're going to have to cut your losses, and you might have to miss a problem and then come back to it. So it's going to be very important that you don't waste too much time in solving some of these. And then Friday, we'll do an exam review. Will be posted. There'll be no video. I haven't determined yet whether there'll be an assignment due with this one yet. Between Friday and then next week, we'll also review for that final going through there. On the Canvas conferences, I will tell you that I am going to be doing some things, not just answering homework questions. I want to go over some things I know have been given some problems on the homework, like on this one here today. I'm going to go over the ones where you get an identity, where you get infinite solutions solving a 3x3 system. And I want to do another one of those just so you see it. And this is one where you have to write the answers like x, 2x plus 7, and then 3x minus 2. So I am going to do a few things different in the Canvas conferences. They will be recorded so you can go back to them. Well, this weekend was supposed to be prom, and I hate to, most of you guys are juniors and seniors. It was your first, for your juniors, your first prom. For some of you seniors, it would have been your last one. So just kind of here's a little memory that, you will not have, and maybe that's a good thing, because I know, fellas, you're probably pretty jealous of the white tails and the pink cummerbund and bow tie. And ladies, I know you're wishing you could have a dress like that for your prom. So that is 1987. That is junior year. So a lot of you guys right there. And I know you're probably pretty jealous of that feathered hair as well. So at least you will not have this picture in your wallets for a few years. Good thing I found this at my parents' house when we were kind of digging through some things there. But yeah, just some memories there for you. All righty, let's actually do something productive. This is 81 from that homework. Some of you got it correct. Some of you did miss it. I want to go over it. On our test, it will be all calculator, so I'm going to have to be creative and doing a couple things and how we set some things up, because I will allow your calculator for everything. B inverse is 1, 2, 3, 4, and then they're telling you this product is negative 1, 3, 0, 2. You do not have to figure out what B is, and I don't even know if that helps you in some cases. Here's how you do this problem. We're trying to find A. Well, we know B inverse, and we know A times B. Well, here's your options. You can either multiply B, if you multiply it on the left, you multiply it in this order, or we can multiply AB times B inverse. Well, here's the way we have to do it if we're looking for A. We need to multiply it in this order because, remember, it's not commutative, and this puts B and B inverse next to each other, and B times B inverse is going to give you the identity matrix, and the identity matrix times any matrix gives you that value back. So in order to solve this one, you have to take negative 1, AB, negative 1, 3, 0, 2, and then B inverse, 1, 2, 3, 4, in this order. And then when you multiply that, you got to take row times column. That's negative 1 plus 9, which will give you 8. And then this row times second column, negative 2 plus 12 gives you 10. And then second row times first column is 0 plus 6 is 6. And then 0 plus 8 is 8. So this is the answer to 81A. A lot of you got it. Probably more than normal didn't. So I just want to make sure we go over that. Also, for the test, like I said, I'm going to have to be creative. So technically, you can type these into your calculator and multiply it. It might be a time issue, but you can. So here would be a situation that you will see on the test possibly. So let's say A times B is going to be a matrix C, and B times A is going to be matrix D. One thing I can ask you to do is just find C31. Well, what is that? That is going to be A times B is going to be the third row times the first column. So matrix C has to be a 3 by 3, okay? It's going to be a 3 by 3, and 3, 1 will be this spot right there. Well, how do I find that? Well, here's A, 2, negative 4, 1, 0, 3, negative 5, 8, negative 3, 2, times B, which is 1, 9, negative 2, 6, negative 4, 0, 8, negative 1, 4. So if I only want to, I want your work. So you got to show me without going through every step. Like I know you can type in your calculator and tell me what that number is, but you got to show me specifically how to get that number. So that number right here, we get with the third row times the first column. So what would you do? You would have to show me. You'd take 8 times 1 plus negative 3 times 6 plus 2 times 8. And then that's 8 minus 18 plus 16. And what do we get there? We get a 6. So that's all I want is that one spot, which is 6. But you got to show me how you get there. Now, I'm not going to go through this one due to time, but so if I ask you what D, this product is the second row, second column, but you'd have to start with B first, the row of B times the column of A to get what that is. Okay, so we'll go through over some of those maybe in a conference or two. But that is a way I'll allow you to use calculators and still be able to test you to see if you know what's going on. So because normally we have a no calculator and a calculator part, but that's not going to work this time. Okay, we're going to move into section 9.4, determinants and Kramer's rule. So today is the 4th. We're going to calculate the determinant. We're going to talk about minors and cofactors, but we're not going to get too far into those. And the main thing is going to be Kramer's rule. Okay. So here we go. The determinant of a 2 by 2 matrix. So let matrix A be A, B, C, D. The determinant you'll see is DT, determinant of A, or this notation, like the absolute value bars. So you have got to be careful how you write the matrices out, because a regular matrix will have that little indentation here. If you just do straight lines, you're telling me that is the determinant, which is something totally different. Well, it is defined by AD minus BC. So you always go from left to right from top to bottom along that diagonal, and then you go from minus BC. That is the determinant of A. Okay, it is on your calculator. If you go to second matrix, if you go to math, that number 1 right there is DET, determinant. So if you hit determinant, and then you type in matrix A. Now, I'm not sure what it's going to say, because A is a 3 by 3. It'll give you an answer. Okay, but there's a lot of math involved in that. All right, evaluate the following. The determinant of negative, this matrix here, negative 6, 5, 4, negative 3. All right, the determinant is we go negative 6 times negative 3 minus, then we go 5 times 4. Well, that's going to be 18 minus 20. The determinant is negative 2. Now for this second one, the determinant is 2 times 18 minus, Okay, the only thing you got to really watch is your negatives. Is -9 times -4, 36 minus 36. You get 0. Well, when we get a matrix with a determinant of 0, that's going to be important as we kind of move forward here. All right, in your calculator, now here's the thing. If you had 2 by 2, it's easier to do it by hand in my mind, because what you'd have to do is you have to go in here, you have to enter it. You got to enter it as a 2 by 2. And then let's say I got 2, -9, -4, 18. So you type in your matrix, you got to quit out of there. Then you go to second matrix, you go to math, and that first one is the determinant. Then you got to use second matrix, A, and it gives you 0. Way easier just to do 2 by 2 by hand. Now 3 by 3 is a little bit easier with the calculator. All right, Kramer's rule is a way to solve a system of equations that involves determinants. As you take a look at here, this is Kramer's rule. Now, they talk about here, x is this d sub x divided by d, and y is d sub y divided by d. Well, those are defined right here. These are determinants based upon the coefficients. Well, d is the coefficients. Let's see here. So your coefficient of x is right here, and then your coefficients for the y's go here. That gives me d. Well, d sub x, what you do is you take the x's out, the coefficient of the x's, and you put in the constants, whatever it equals. So you have to have it in this format. So this is where the c's goes for d sub x, and for d sub y, this is where the constants go here. This is Kramer's rule. Let's take a look at solving an equation with Kramer's rule. We have to find 3 determinants. All right, D is the determinant with just the coefficients of x and y. And it has to be in this order. You have to put everything, all the x's line up, all the y's line up, equals a constant. So D is going to be 5, 4, 2, 3. And that is going to be the determinant. And we find it by doing 5 times 3 is 15 minus 4 times 2, which is 8. So D is 7. All right, D sub x. You take out the x coefficients, the 5 and the 2, you replace them with the 1 and the 6. And here we got 4 and 3. And same thing, D sub x, you find the determinant by doing 1 times 3, which is 3, minus 4 times 6, which is 24. 3 minus 24 is negative 21. And D sub y, you take out the y coefficients, the 4 and the 3. So the 5 and the 2 come back, and the 4 and 3 go out. You get 1 and 6. And so D sub y is 5 times 6, which is 30, minus 1 times 2, which is 2. And you get 28. Now, there's obviously a lot of math that's behind this of why it works that we're really not, it's just too hard remotely to get into it. It's in your book if you need to look it up. But this is Kramer's rule is always going to work with a 2 by 2 system using this format. Now, we haven't figured out what x and y are. X is d sub x divided by d, the determinant of this matrix, which is negative 21, divided by the determinant 7, so we get negative 3. Y is d sub y divided by d. D sub y is 28 divided by 7, which is positive 4. So it would just be the ordered pair, negative 3, 4. Just another way to solve a system. Okay, another way to solve a system. All right, go ahead. You try it. I'm going to pause it here for a second. While I'm paused, you see what you come up with. If you want to use your calculator, that's fine, but you don't have to. Okay. Hopefully while you paused it, I did a little bit of work because And then for D, you just use your coefficients. I got 4 minus 9. My determinant is negative 5. D sub x, remember you take out the x coefficients, you plug in the constants, 146 and 66. I got D sub x as 80. And for D sub y, get 4 and a 9, and you put in 146 and 66 for the y's, and now we get a pretty big number here. I end up with negative 1,050. All right, well, from here, x is D sub x divided by D, which is 80 divided by negative 5. 80 divided by negative 5 will be negative 16. Y is going to be D sub y divided by D, negative 1,050 divided by negative 5. So y equals 210. So in the end, the ordered pair, negative 16 to 10, would be the answer. Okay. Now, like I said, you can use your calculator. Not too hard to figure out the determinants of a 2 by 2. Okay. Now, once we get into 3 by 3s, you can only find the determinant of what we call a square matrix, an n by n matrix, a 2 by 2, a 3 by 3, a 4 by 4. It gets a little bit more complicated once we get into 3 by 3s and 4 by 4s. And they're going to talk something about a minor and a cofactor, and they're going to go through this. Normally, I go through and at least kind of explain all of this because this is one way to figure out the determinant. But I'm not going to do this this year. I'm just going to kind of show you the basic way to find the determinant of a 3 by 3. I guess it's a little bit of a trick, but it's a lot easier than going through minors and cofactors. So technically, you don't even need to worry about them. Okay. The determinant of a 3 by 3 matrix. So here's the actual formula, or kind of how to do it. And it's not going to make a lot of sense right now. It says let A be a square matrix of n greater than equal to 3. It's 3 by 3, 4 by 4. The determinant of A is the sum of the entries in any row of A or column multiplied by the respective cofactors. Well, cofactors were determined back here. Like I said, we're not going to worry about this method at this point. Let me show you how we're going to find the determinant of a matrix 3 by 3. You will need to know how to do it by hand, and you can use your calculator as well. All right, here's how we do a 3 by 3. You have a 3 by 3 matrix. You need to write it down, and what you want to do is you want to recopy the first 2 columns right next to your matrix. So I'm going to go 3, 1, 4. I'm going to go 4, 4, 3. Here's how we do the determinant. We are going to multiply along the diagonal, similar to a 2 by 2, but we're going to have more diagonals. We're going to multiply along these 3 diagonals. Okay, and then when I do that, okay, you're going to take 3 times 4 times 1, which is 12. Plus, you're going to multiply 4 times 3 times 4. Well, that's 4 times 3 is 12, times 4 is 48. Plus 1 times 1 times 3, which is 3. Now that's part 1. Minus, you are going to multiply along the diagonal starting on the top right. Okay, so to write these rows, again, it just kind of helps us line everything up. I'm going to subtract now 4 times 1 times 1, which is 4. Now you add these again. 3 times 3 times 3 is 27, plus 1 times 4 times 4, which is 16. So that equals 63 minus 47, and that is 16. That is the determinant. The determinant is a constant. Now in your calculator, if you're going to use your calculator, you'd have to input the 3 by 3, and it was 3, 4, 1, 1, 4, 3, 4, 3, 1. and then you got to quit. And then to find the determinant, you have to do second matrix, go to the math menu, determinant, second matrix, and it's matrix A, and it's 16. Get the same thing. So you can use your calculator kind of as a check. Like I said, you're going to have to know how to do this by hand because there's going to be a few problems where the calculator will not work. So when you have a problem with variables in it, okay, you're going to have to know the method. So the method here is you take your first two columns and recopy them. And we're going to multiply along from left to right along those diagonals, and we always add, okay, in this first step. So it equals zeros together, multiply it to give you 0. X, z times x times y. I'm just going to write that as x, y, z. Plus y times z times x. Only way, that's just x, y, z. Minus. Now we go from top right to bottom left. And what do we get here? I get z times 0. Well, it's going to be nice when you end up with zeros anywhere because 0 times x is a 0. And y times 0 times y is another 0. So what I end up with is, that's a 0. So you end up with x plus, xyz plus xyz minus 0. Well, what's xyz plus xyz? That is just 2 xyz. That would be your determinant for B. Now we can also use Cramer's rule for 3 by 3. And it is exactly the same as your 2 by 2 in just kind of the format. We're going to find 4 different determinants. Let me go here. 4 different determinants. You got D, D sub x, D sub y, D sub z. Okay. You got D, D sub x, D sub y, and D sub z, where for the D sub x and the D sub y and the D sub z, you take out, like for the x, you take out the x coefficients. For D sub y, you take out the y coefficients. And for D sub z, you take out the z coefficients and you put in the constants, which were here. Okay? But the procedure is really the same. All right, we are going to solve a 3 by 3 system by hand. One thing you have to do, though, is you have to have the x's, the y's, and the z's lined up, and you have to equal a constant. So this one, I need to do a little bit of work. And if you have a set, if you're missing a variable, make sure you put in a 0 for that. So for this one here, I got to make this 7x plus y plus z equals 1. And this has got to be 5x minus 2y plus 3z equals 4. And then I got to make this one 4x plus 3y minus z equals 0. So now you got to do that or Cramer's rule won't work. All right, now this will be tedious. Once you get to this, you can use your calculator for any 3 by 3 determinant. Okay, it's going to save you time. It'll save you a headache. Now, normally we split up the work here. So let me do the first one. So D equals, and you got the determinant. You get 7, 1, 1, 5, negative 2, 3, 4, 3, negative 1. Okay. And then I'm going to type that in. Second matrix, edit. And it's a 3 by 3. I get 7, 1, 1. Only problem with using your calculator really for anything is if you type something in wrong, then you're going to be automatically wrong. So 4, 3, negative 1. All right, and then I got to go second matrix, math, determinant, and then I got to tell it what I want the determinant of the matrix A, and it gives me negative 9. Okay, d sub x. You take out the x's, the 7, 5, and 4. You take out those and you put in the constants. We put in 1, 4, 0, but your y coefficients stay the same. 1, negative 2, 3, and then 1, 3, negative 1. And just to save time, I'm going to tell you that one is 9. I'm going to tell you the next two as well. If you want to type them in and verify, go right ahead. D sub y, I take out the y's, which are 1, negative 2, and 3, and I put in the 1, 4, 0. And everything else stays the same. And then when you take the determinant of that one, it gives us negative 27. And d sub z, we keep the x coefficients and the y coefficients the same. So it should be 7, 5, 4. It should be 1, negative 2, 3. We take out the z's and we put in the constants, which were 1, 4, and 0. And when you type that in, we get negative 45. So x is d sub x over d. D sub x is 9. D is negative 9. X is negative 1. Y is d sub y over d, which is negative 27 over negative 9, positive 3. And z, d sub z over d, which is negative 45 over negative 9. Whoops, let me do that over there. And what does that give us? Positive 5. And so your final answer is an ordered triple. This is the answer to the system. Negative 1, 3, 5. Got it? Negative 1, 3, 5. So that's how you use Kramer's rule. Now, typically what I do on a test is I'll give you a 3x3 system and I'll just say find the x value. Don't find everything, just find the x. Well, you only need to find 2 determinants to find the x. Don't go through the whole procedure. Okay, and we'll go through this tomorrow and when we review. Got it? And on your review. All right, here's your homework. Page 923, 50 and 58 both say use Kramer's rule. They're both have 3x3s. Use your calculator. Type everything into your calculator. That's absolutely fine. Got it. These are 2x2s. You're probably going to be fine just calculating those by hand. Okay. You can use your calculator if you want. You don't have to. All right. I hope everybody's doing well. Get this done today. Do your best. It's not due till tomorrow, but you're better off to get this done today as we start to move into the review. Got it? Test is on Thursday. All right. Everybody have an awesome day.